Hello, my name is Dipen Yadav and my student number is 25109990022. This video presentation covers task D1, analyzing YouTube video data from news publishers. In this task, I have collected data from four news channels: Fox News, BBC News, CNN, and MSNBC. I have chosen climate change as my topic for analysis, so I focused on the keywords such as climate change, global warming, and carbon emissions. And the data collection spanned from January 1, 2022 to January 1, 2025. I will now walk you through the steps taken in this file to complete the analysis. Starting with section D and prepare the data, I checked if there are any missing values or not. So to check for missing values, I use .info method. As you can see in the data frame videos.df, there is a missing value in the tag column. So here I use .filna method to replace the missing values with the empty space. Next, basic preparation has been done here to help with data analysis, so there is no further need for preparation. In this task, I choose to answer three questions: E1.1, E1.6, and E2.7. First, for E1.1, the task was to compare the distributions of the number of views, likes, and comments for all collected videos using a visualization that includes three subplots with histograms and kernel density estimates. In this question, I have used NumPy, Seaborn, and Matplotlib library to make a histogram. First, I defined two lists, one called distribution underscore columns, which stores the column names from our dataset, and another called titles, which stores the names like likes and video comment count. This will help us look through the data and label our graphs. Next, I create a figure with subplots using this command. This means we'll have one row and three columns of graphs. Now I use a for loop to go through each column. Enumerate gives us both the index and the column name, so we can easily access the right subplot each time. Inside the loop, I apply a log transformation to the data using np.log1p. This step is really important because video data can vary a lot. Some videos might have hundreds of views while others have millions. Taking the log helps to compress that wide range and makes the graph easier to read. Then I plot two things, a histogram and a KDE curve. The histogram shows in light green displays how often value appear. The red KDE line gives a smooth curve that represents the overall distribution shape. Together they give a clear visual picture of the data. After that, I set the titles, axis labels, and legends for each subplot so everything is clearly labeled. Finally, I add one big title for the whole figure using plt.subtitle. Adjust spacing with tight layout and display the result with plt.show. I can observe from these graphs that most videos cluster in a central area. That suggests view videos having extremely high view counts. The likes and comments distributions look quite similar to each other, showing that the majority of videos received a comparable amount of likes and comments. Next, I answered E1.6, which asks to compare the ratio of likes to views for the top 5 videos by the number of views. This ratio helps identify which videos resonated most with the audience, regardless of the channel's overall size. First, I have created a new column in our data frame called like to video ratio. This shows how many likes each video got from every view. I am using np.where to avoid dividing by zero. It checks if a video's view count is greater than zero. Then it divides likes by views. If not, it simply puts a zero. This helps us avoid errors from videos that might not have any views yet. Next, I sort all videos by this ratio using this command. This means we are arranging the videos from the highest like to view ratio to the lowest. The video at the top of the list are the ones that people like the most compared to how many viewed them. Basically, they perform the best in terms of engagement. Next, I used this command. Here we are showing the video title, its YouTube link, the number of links, the number of views, and its like to view ratio. The resulting table for the top 5 videos clearly shows that one video, What Trump Thinks About Climate Change, had the highest ratio at about 3.39%. The other 4 videos have lower ratios, all below 2.6%. Even though the second place videos have much lower view counts, it was still decent enough to have 2,163 likes. Finally, question 2.7 asks to compare the average number of videos published per week by each news channel. In this question, I have used Pandas and Seaborn library. First, I set the columns published at as the index using this command. This organizes the data based on when the video was published. It's important because we're grouping our data by week and Pandas need a date time index for that. Next, I use this command. This group all videos by their channel title and the use of resample W organizes the data by week. And finally, I count how many videos are uploaded each week by each channel. This gives us the total number of videos published weekly for every channel. Now I calculate the average number of videos per week by using this command. This tells us on average how many videos each channel posts per week. To make it easier to understand, I rename the column video underscore ID to average videos per week. Next, I visualize this using a bar chart using this command. Here, the x-axis shows the channel names, the y-axis shows the average video published per week, and each bar represents one channel. Finally, I add a title, adjust the layout, and display the chart using these commands. One tricky challenge I faced was with the numerical data, especially for views, likes, and comments. As we saw in question E1.1, most views have low engagement, but a few videos have millions of views. These are outliers, meaning it's not evenly spread out. This was an obstacle because these huge numbers can sometimes make the average or mean value misleading. To fix this, I used logarithmic transformations on the data to see patterns in a chart, which helped me to reduce the squares and show the data more clearly. So this concludes my presentation of task T1. Thank you for watching.